Alrighty, hello. So you should have done the POGL already on electron configuration. So this video is going to go over those notes that you should have hopefully picked up a little bit on the POGL, but go into a little more detail so you can have some concrete notes. You will need your periodic table in order to do this. So electron configurations. Electron configurations can be kind of tricky at first, but after you get the hang of it, they're going to be much easier. And there's three major rules to think of when building an electron configuration, which we talked about last week when we talked about quantum numbers, but didn't go into detail about. So these are called the Aufbau principle, the Pauli exclusion principle, and Hund's rule. So the first one, the Aufbau principle. The Aufbau principle states that electrons occupy orbitals of lowest energy first. Okay, and this isn't news to you. You know that this happens. When we draw our orbitals in our orbital diagrams or in our Bohr diagrams, we draw the first level first. We fill in the first orbital before we fill in the second one. So we have to put 2 electrons in before we can fill in the second one with the next electrons. Okay, so that's what the Aufbau principle states. It just states that electrons occupy orbitals of lower energy first. Our second, well, this is just another picture of that. So 1s comes first, and then 2s, and then 2p, 3s, 3p, which we'll talk about in the next couple slides. So our second rule we're going to focus on is the Pauli exclusion principle, and this connects to the electron spin quantum number that we talked about last class. So remember that electrons can either spin up or they can spin down. So they have that positive half or they have the negative half to tell us which way something is spinning. So an orbital can hold up to 2 electrons, and these 2 electrons have an opposite spin. So notice here, these 2 arrows each represent an electron. Notice that this one is pointing up and this one's pointing down, so one is spinning upwards while the other is spinning down. Okay, and that's what Pauli exclusion principle states. It just states that they have to spin in opposite directions and able to be in the same orbital. And then our last rule we're going to look at is Hund's rule. So Hund's rule just states that electrons occupy separate orbitals rather than pair. So electrons don't really want to pair unless they have to. So kind of like the seats on a bus. When you get on a bus, you prefer to sit by yourself. You only double up on the seats of a bus when there's no other seats available. So notice in this picture that in the 1s, there's 1 electron going up and 1 going down. In 2s, there's 1 going up and 1 going down, but notice in 2p, there's 3 available orbitals for electrons to join into. There's only 2 electrons, however, so 1 goes into the first and spins up, and 1 goes into the second and spins up. They're not going to pair because they don't have to. They have an open orbital for them to sit in. So, the rules of how to draw an electron configuration follow this mapping. So we're always going to start with 1s, then we're going to go to 2s, and then 2p to 3p, 3p to 4s, and 3d to 4p to 5s. And these are arranged in the periodic table, which I'll show you how it's shown in a periodic table in just a moment. Remember that that 1 signifies our principal quantum number. So that 1 is telling us what shell it's in, what energy level it's in. So 1s is in the first energy shell. The s tells us our angular momentum quantum number. So the s is telling us our shape. So we're in the first level and we have an S shape. Okay, and an S shape is representative of just a circle. Okay, it's just a sphere looking orbital. So the 2s then is on the second energy level. It again has a spherical shape, but there's also a 2p level. So it's in the second energy level still, but there's a different orbital that things can join, and it's in the shape of a p, which isn't really a p. It's kind of like a globular shape, which I'll show you in the next couple slides as well. So before I go through some more definitions and stuff, I want to just show you how to write one of these. So there's a couple different steps that you can follow when writing electron configurations, and these are in the note packet that I provided you, so you don't have to write all this down. So your first job is to determine how many electrons are in an atom. So let's say we're writing an electron configuration for iron. When you find iron on your periodic table, you find its atomic number, and you can see that iron has 26 is its atomic number, showing it has 26 protons, so it has 26 electrons. Okay, you're going to arrange the energy sublevels according to increasing energy. So like we showed you in this slide, you're going to write them out as 1s, 2s, 2p, 3s, 3p, 3d, and so forth. And then each sublevel can be filled with different amounts of electrons. So this is what we haven't gone over yet. Different orbitals can hold different amounts of electrons. Okay, so I'll write them here. The s orbital can hold up to 2 electrons. Okay, the p orbital can hold up to 6 electrons. For now, that's all I want you to know. Just know that the s holds 2 and the p can hold 6. So basically, what you're going to do in order to write the electron configurations for these things is write 1s, 2. Oh, that's a bad looking s. 2, as shown here. And so we use 2 electrons. We then go to 2s2 and add another 2, so we've used 4. We go to 2p6, so now we've used 6, 7, 8, 9, 10. 3s2, 12. 3p6, 18. 4s2, 20. And then 3d6 to get to 26 total electrons. So we can use the periodic table to help predict which sublevel is going to be filled up by different elements. So the periodic table is broken up into what are called different blocks. So these first 2 columns here are what is called the S block. This middle section is the D block. This green is the P block. And then here too we just have an extra helium that belongs here. And then the purple at the bottom is the F block. Okay, so if we're looking here, we know that boron is located here in the P block. We would go 1s, 1, 2. So 1s2. We'd go into 2s, 2, and then we have 2p, 1. Okay, again, this is going to be a little bit confusing at first, so we're going to try a couple more practice problems. I'm going to go ahead and pause and bring up a whiteboard on our screen here so that we can do these together. Our first example we're going to look at is argon. Alrighty, so like I just said, we're going to look at argon first. Make sure you have your instructions in front of you. It says our first step is determine how many electrons are in the atom. So find argon on your periodic table, and once you find it, you'll see that we have 18 electrons that we're dealing with. Okay? We know that 1s always comes first. We always have a 1s orbital first, and an s orbital holds 2 electrons. Unfortunately, oops, see, that is not the button I wanted. One moment. Unfortunately, it won't let me do an exponent on this whiteboard, so we'll just have to pretend that it's in the exponent spot. So we have a 1s2 orbital. So we've used 2 electrons, but we're not done yet. We have to jump over to the next s level, so we're going down. So we've used up hydrogen and helium, we're jumping to lithium. So we have 2s, 2, because again, it can only hold 2 electrons. After we go to 2s2, you can see that in our periodic table, which is here, oh, if I could make it bigger, that'd be great. This video is going great for us, I'm so sorry. So here, we went from a 1s2 to 2s2, we have to jump over to 2p, and our 2p can hold 6 electrons. So our next thing is 2p6. Okay, so we have 1s2, 2s2, 2p6. So far we've used 6, 7, 8, 9, 10 electrons. So our next level to go to is 3s2. And then we have 3p6. The way you can check these is first to make sure your orbitals go in order. 1s, 2s, 2p, 3s, 3p, and then count up your electrons. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this would be our electron configuration for argon. I want you to try potassium and copper on your own for a moment, so go ahead and pause your computers, and then when you're done, go ahead and unpause them and I'll show you the answers. Alrighty, hopefully you have your answers, so if we go to our next screen here, maybe, These should be the answers you received. I didn't tell you this earlier, but your d orbital can hold up to 10 electrons, okay, because they're going to have 5 different orbitals that you can fill up, so giving you a total of 10 electrons. So go ahead and check your answers. I am going to post another supplemental video that goes over this in more detail too if you're still confused, because I know this is a very tough topic to learn virtually. But if you have questions, please reach out. Thank you.